Hello, algebra students. This is Mrs. Crayer. I'm going to make the video for day 4. I am using a stylus that is not great, but it's the only one I have, so I'm going to apologize in advance for my writing. Hopefully, it's not that bad. Okay, I'm on page 10, exploring the graphed quadratic equation, day 4. Let me try and zoom in a little bit. Okay. So, quadratic equation. This should not be the first time you've seen this. We are talking about y equals ax squared plus bx plus c. What makes it a quadratic equation? Well, that right there, the squared. It's a quadratic if the highest exponent, or the degree, is 2. Okay, x-intercepts when y equals 0. So if this thing I'm pointing, which you can't see, if that thing that I just wrote is equal to 0, and we solve, that's what we did in Unit 10, the answers are called the roots, or zeros. That says zeros of the equation. So as you can see here, we set it equal to 0. We learned how to solve by factoring. We learned how to solve by completing the square. And we learned how to solve by the quadratic formula. All of the answers that we get after we set it equal to 0 and solve those are the roots and the zeros. Okay. So determine the number of roots illustrated in each of the picture below. Well, if the roots and the zeros are the x-intercepts, as stated here, then we look at the picture and determine where it touches the x-axis. In the first picture, I'm seeing that there are 2 zeros. Just kind of zoom this up a little bit. I can see that it hits the x-axis twice. So we've stated there are 2 zeros, and then we're going to state what the zeros are. One of them is x equals 1. That's where one of the x-intercepts is. The other one is at x equals 3. In the next picture, you can see this parabola only touches the x-axis once. So that means there's 1 zero. Where is that 0? Be careful, you're going left, so it's negative. And it's at x equals -3. In the last one, you can see that that parabola doesn't hit the x-axis at all. So I would say this one has no roots or zeros. Okay, coming down here to number 1. Given the following graph, determine each of the following. So we're starting with the axis of symmetry. And the axis of symmetry, as you've seen already in this packet, that's going to be this line right here that cuts the parabola in half. It's a vertical line, so remember, hoi vux is going to be an x equals. And you can see that that's right in between those two values on the x-axis. So we're going to count over. 1, 2, 3.5 is where that line is. So x equals 3.5. What are the coordinates of the vertex? Another name for the vertex is the turning point. Its x value is at 3.5. The y value, I'm just looking at that point right there, and it's down 2, so -2. Is the turning point a max or a min? Well, this is a facing up parabola. It would have a positive a value, which makes it have a minimum. How many zeros are there? This is relating to what we did above. This parabola hits the x-axis 2 times, so there are 2 zeros. What are the solutions to the equation? Well, the solutions are the answers to the zeros. That's what we were doing above. I can write them out separately. I can see that it hits the x-axis at 2. Okay, I got cut off there for a second, so hopefully this is on the same video. I can see that it hits the x-axis at 5. Now, I can write that separately, like I just did, or I can write it in this set notation and just kind of list them out. If I'm going to do this, then I need to use the squiggly brackets, not to be confused with like domain. All right. Some follow-up question. What factors did the solution of the graph come from? So, think back to solving. I was mentioning solving at the beginning of the top of the page. If we were solving, at the end of the problem, we would have x equals 2, and I'm going to draw a line in between them because this is what your paper would look like. X equals 5. This question is saying, if I have x equals 2 at the end of solving, what would the factor have been? You guys should be thinking of that answer before I write it down. In this part, we would have had this equal to 0. This would have been right before we did, sometimes this is called the t-chart. What would have been in the parentheses? An x minus 2. In order for me to get x equals 5, what would have been in the parentheses? An x minus 5. These are the factors. Not to be confused with, not to be confused with these, which are the zeros. This is going to be really important. To be able to look at a parabola and say, okay, it hits at x equals 2, it hits at x equals 5. If those are my zeros, can I work backwards to find the factors? You should be able to. If this is x equals 2, back in the parentheses would have been an x minus 2. If that was a negative 2, back in the parentheses it would have been an x plus 2. Use these factors to determine the equation of the graph. Well, I can say that the equation of the graph is, I'm just going to change colors here, y equals x minus 2 times x minus 5. That would be in factored form. But really I want it in standard form. So to get it in standard form, I'm going to multiply these factors out. So I've got x minus 2, x minus 5, x squared minus 5x minus 2x plus 10. When I combine like terms, I'm going to get x squared minus 7x plus 10. Okay, and I'm kind of running out of room here, but I do want to point out that this is factored form, and this is standard form. Now, those are the equations of the parabola. If I type, this is typically what you would see. If I type this into y equals in my calculator and graph it, I'm going to see that parabola. Okay, let me go on to the next page. Okay, now I'm on page 11. If you don't have your calculator out, you're going to want to pause this and grab your calculator, because when it says to graph a parabola, we are definitely using our calculator. We always want a table on the page, and in order to get a good table, we should know where the turning point's going to happen. So in order to know where the turning point's going to happen, I'm going to use x equals negative b over 2a. And again, a equals negative 1, b equals negative 6, and c equals negative 5. So negative 6 is positive 6 over 2 times negative 1. This is going to be 6 divided by negative 2, which means x equals negative 3. That helps me because then when I go put this in y equals, I know that I want negative 3 to be in the middle of my table. So I'm going to put that in y equals, and then I'm going to get my table set up. Negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. And if you typed it in and you're looking at the table, it should look symmetric. So this is negative 5, this is 0, this is 3, 4, 3, 0, negative 5. And it does look symmetric to me. I can see that this certainly is where my turning point is. If I'm looking at these values, they're going up, negative 5, 0, 3, 4, and then at the turning point, they change from going up to going down, 4, 3, 0, negative 5. Okay, I'm moving over to my graph, and I'm going to plot these points. So negative 6, 1, 2, 3, 4, 5, 6. Negative 5, 1, 2, 3, 4, 5. Negative 5, 0. Negative 4, 1, 2, 3. Negative 3, 4. Okay, so I'm going to try and make those points a little bit clearer and nicer. And there is my parabola. Why does it face down? Well, it faces down. I was expecting that because of this negative right here. Next question, what are the solutions of this equation? I'm going to use that set notation like I used before, and I'm going to list them in squiggly brackets. So I'm looking at the x-intercepts. I see one of them at negative 5 and one of them at negative 1. Okay, so last part of this. Bottom of page 11, procedure for writing an equation for a graphed quadratic function. So we kind of already started this on the last page. It says determine the roots and zeros of the function. So that's the first thing I want to do. Looking at this first parabola, it's facing down. I can see that it has a 0 at x equals 0. It also has a 0 at x equals 4. So I want to start by setting it up in factored form. We're trying to come up with an equation, so I want to start with y equals. Now, what would the factor be if it was x equals 0? Well, whenever I have an x equals 0, my factor is If I want it in standard form, I'm going to have to distribute this. Now, because this is just a monomial, I can distribute the negative and the x at the same time. That's the only reason I'm allowed to do that here. Negative x squared, x times x is x squared, plus, how did I get a plus? Because a negative times a negative is positive, 4x. That is standard form. Last one. My zeros are 3 and 5. In factored form, this is going to look like x minus 3, x minus 5. I do not need a negative here because it's facing up. I'm going to multiply these out. Combine like terms. This one is in factored form. This one is in standard form. Now, quick note. If there was a negative out in front, there is not, but let's just pretend for a second there was a negative out in front. Then I would need to keep this in parentheses and then distribute the negative last. I would not be able to distribute the negative prior to or at the same time as I multiplied them out. That negative would have to be done last. I'm going to erase that because there was no negative. All right, hopefully that wasn't too messy. I'm going to, like anything, hopefully I get better at this as time goes on. All right, thanks everybody.